All right, so continuing on with our quadratic functions, I want to look at how we can graph this function in example 3. F of x equals negative 1/2 times the quantity x plus 3, closed quantity squared, all plus 3. So what I want to do is identify the vertex first. So find where like the middle part of my graph is going to occur and then work our way out. So if you look back at what we talked about in our last video, vertex form, our vertex form, f of x equals a times the quantity x minus h, closed quantity squared, plus k. The vertex is hk, is determined by these two values. So instead of starting at the origin, we don't trust our x's. So this x plus 3 tells us that we are going to start at negative 3 for the x coordinate. So I'm going to go ahead and put a negative 3 in right here. Do not trust your x's. So where it says a plus 3, we are going to have a negative 3. And then the y value of the vertex is going to occur at a positive 3. So then I'll move this up. So this should be my vertex, and then if we want to be careful, we can type that into our TI-84 or some other calculator. Negative 1/2 quantity x plus 3, closed quantity squared, plus 3. But I want to see what happens when x is negative 3. So replace x with negative 3, and we will get a positive 3. So there's the vertex. And then we're going to work our way around that. So as we go to the right, we would get to negative 2 and negative 1. As we go to the left, we would have negative 4 and negative 5. So then I'm going to see what happens here. If I go to the right and replace x with negative 2, I get a 5 over 2, which you may also know as 2.5 or 2.5. And then remember, since there is symmetry in this graph, it should be the same thing on the other side. 5 over 2 equals 2.5 if I put a negative 4 in there. And I'll just show you that that is, in fact, what happens. We still get a 5 over 2. And then if I put in a negative 1 or a negative 5, we get a 1 either way. So that tells me 4 more points that I can use to graph this function. So we've got, after negative 3, 3, we also know negative 2, 2.5, and negative 4, 2.5. And I know negative 1, 1, and negative 5, 1. So then connecting the points on my graph here, you see we should get something like this. So now to go along with what we've done before, we've already said that the vertex occurs at the point negative 3, 3. The axis of symmetry would be the vertical line right down the middle. So in this case, that is x equals negative 3. The domain, as with most of these, is going to be all real numbers, because I can put any real number in for x to get something out of it. And then look carefully at your graph and see what we think the range should be. What is the set of all possible outcomes on this graph, all possible y values? The maximum occurs at 3. So the highest value possible is a 3, meaning our range is all y values less than or equal to 3. We can be 3, we can be less than 3, and that's it. Okay, so now moving on to a different type of problem, but using a lot of the same logic. In example 4, I give you a graph, and I want you to tell me what equation matches the graph. So there are 2 steps that we need to really follow. Find the vertex and then find A. So the vertex, I think, might be a little bit easier here. We'll start with that then. So the vertex is HK. So it's this point right down here. It's the minimum of this graph. It's either a minimum or a maximum, and it occurs at 1, -3. And then we're going to try to find A. So what is my A value here? So again, refer back to what we talked to yesterday. We've already found the vertex. What is A? It tells us a couple of things. Is there a stretch or compression? And does it open up or down? So perhaps the easiest thing to tell from this graph is that this is a regular U shape that's opening up. So since it opens up, we're looking at a positive A. And then has there been a stretch or a compression? So typically what happens is from our vertex, the next point we find is right one, up one, left one, up one. That's not the case here. When we go over 1, we actually go up 2. So we have a vertical stretch by a factor of 2. So we know A is positive, and there has been a stretch by a factor of 2, so we know that A is 2. And then that's the only two things we really need to identify in order to answer this. So we know that generally the formula is f of x equals A times the quantity x minus h quantity squared plus k. But in step 2, we determined that A was 2. And we saw that the vertex occurred at 1, -3. We don't trust our x's, so we're going to make that a -1 in here. And k is going to stay the same, so k is going to be a -3. So if you find the A value and find the vertex, you should be able to write this equation in vertex form. And then we can graph to confirm that this is correct. So if we go to y equals, clear out anything we already had, do 2 times the quantity x minus 1 closed quantity squared minus 3. That looks right to me. I'm going to graph it. And that looks pretty similar to what I've got there. The vertex occurs in the 4th quadrant. It opens up. It looks like it's been stretched. So that seems like a pretty good match. And then we can check on, not Wolfram Alpha, on Desmos as well. So y equals 2 times the quantity x minus 1 closed quantity squared, all minus 3. And again, that looks just like what we have here. So I feel pretty good about my answer there. Then there is one more example I want to do today. We are going to do example 5. We are not going to do example 6. So here, go through those 2 steps again. What is the vertex? The vertex is, in this case, a maximum at -1, 2. And then we want to determine what A is. So typically, it opens down in this case. And there is no stretch or compression. So that tells me that A is going to be negative because it opens down. And since there's no stretch or compression, it's just going to be a -1. So then typically for this problem, if we want to write it in vertex form, it is f of x equals A times the quantity x minus h closed quantity squared plus k. A is -1. I'm just going to leave it as a negative sign because if there's no number written, we can assume it's 1 in this case. If you put a -1 in there, though, you are not incorrect. That's all right for me. So then h is -1, but we don't trust our x's, so we're going to put a +1 in there, squared, and then k is a +2. And then quickly I'll verify with the graphing calculator. Negative x plus 1 closed quantity squared plus 2. I did not type that right. Negative x plus 1 closed quantity squared plus 2. Here we go. That looks about right. We've got a vertex that's a maximum in the second quadrant going down. And then again on the Desmos calculator, y equals negative quantity x plus 1 closed quantity squared plus 2. Vertex, it's a maximum in the second quadrant. So it looks good to me. And I think that should do us for today. We'll finish up this section in our next video.